Okay, so this is the last video on the Unit 6, Day 1, dealing with displacement, velocity, and acceleration. And we're going to go through this one example here that we have quite a lot of kind of extension questions about the position function or displacement function that's given here. So we've got s at t is negative 1/3 t cubed plus 2.5 t squared. So the first thing says sketch a graph of this function. So in order to sketch, I'm going to factor, and if I factor out that negative 1/3 t squared, I get t minus 7.5. So that means my zeros are at t equals 0 and t equals 7.5, and that this one is a turning point 0, like what we would have done in advanced functions. So we can do a little sketch. Now typically we would be looking at the and we know that this is a cubic with a negative leading coefficient, so it's going to start up high, come down, up, and end down there. So here we know that this is a turning point 0, and if t equals 0, that would be one of my zeros. Typically, we're not going to include values of time less than 0. We're going to always kind of assume that time starts at 0, but you can kind of imagine that this would be coming down because of that negative leading coefficient in the cubic. It's going to have a turning point here, so I'll draw it coming up. We don't really know much of a scale for anything here, and that's okay. It's going to turn around up there somewhere and come back down, and that's at 7.5. Arrows on the end there. So that's just kind of a rough sketch of a cubic. Again, we're not going to really fill that in because we're going to assume that because this is time, it starts at 0. So then it says find the derivative and sketch a graph of the derivative for all t values greater than 0. So s prime at t, or we could write v at t, would be negative t squared, and then multiplying that in by 2 plus 5t, and that's also, those are equivalent expressions. V at t indicating velocity is a little bit more descriptive. If I wanted to sketch this, I would factor my quadratic. I'm going to factor out a negative t and say that that's t minus 5. So I have a parabola, it's opening down, and it has zeros at t equals 0 and t equals 5. So that's a sketch of my velocity function. And I know there's a 0 here, 0 at 5, and it's an opening down parabola because of that negative leading coefficient. We could figure out what the vertex was. We know that a parabola would have the vertex halfway in between, and v at 2.5, just by subbing that in, is 6.25. So if you wanted to do a little bit more accurate sketch, you could get that vertex point there as well. I'm going to pull this up. So the next part says, when is the object at rest? So we know that the object is at rest when the velocity is 0. So I'm going to say v at t equals 0, just kind of specifying how I know, like, what does at rest mean before I say where that happens. So that happens at time equals 0 and time equals 5. Okay. Then it says determine the direction of motion at t equals 4 and t equals 6. So if we're talking about direction of motion, we want to know whether it's moving in a positive or negative direction. That we need to know whether the velocity is positive or negative. We have a graph of velocity here, so I can tell that the value of velocity is going to be positive at t equals 4 because that's before the 0, and negative at t equals 6. But it's probably best to show an algebraic solution. So I would say that v at 4 is negative 4 squared plus 5 times 4. So that's negative 16 plus 20, which is 4, and I think that these are in meters per second. Yeah. So then I would do the same thing for v at 6, and subbing in negative 6 squared plus 5 times 6. So I get negative 36 plus 30, or negative 6 meters per second. So we could say it's moving in a positive direction at t equals 4, and a negative direction at t equals 6. Okay. Determine the acceleration at 4 and 6 seconds. So for that, we need to find the acceleration function. So going back to my velocity function, I'm just going to rewrite that. We had negative t squared plus 5t. So then the acceleration function is, obviously we've got the derivative of the velocity function. So that's negative 2t plus 5. So we need to find the acceleration at both of these times. So a at 4 equals negative 2 times 4 plus 5, which is negative 3. And that's meters per second squared as my units. And a at 6 is given by negative 2 times 6 plus 5. So negative 12 plus 5 is negative 7 meters per second squared. Those are the units for acceleration. So now we're asked, is it speeding up or slowing down at 4 seconds and 6 seconds? So here at 4 seconds, we know the velocity was 4 meters per second, and the acceleration was negative 3 meters per second. So its current velocity was 4, and it was decreasing in velocity. So it's positive velocity and slowing down. So v at 4 is greater than 0, and a at 4 is less than 0. So that's slowing down. So it's opposite signs. And then we could look at the same thing for 6 seconds. V was negative 6 meters per second, and the acceleration was negative 7 meters per second squared. So here we've got the velocity at 6 is negative, and the acceleration at 6 seconds is also negative. So because these are the same signs, it's speeding up. It's moving in a negative direction because it's got a velocity of negative 6, and that negative 6 is decreasing. So it's going to decrease from negative 6 to negative 7, negative 8, negative 9. Those numbers are decreasing, but they're getting bigger in magnitude. So this means speeding up because it has the same signs. Okay. I am going to squeeze in one last little bit here with the direction. Is it moving away from or towards the origin at these same times? So if I put in S at 4, and I'm actually just going to kind of eyeball it from the graph, we would know that S at 4 and S at 6 are both positive values. It's on the positive side of the origin for both of those values from the graph. So S at 4 is greater than 0, and S at 6 is greater than 0. That means that we can compare the displacement or the position. We've got a positive position at both of those times. So here, the velocity at 4 was positive. So this is moving away from the origin. It's in a positive position compared to 0, and it's moving in a positive direction. It's moving away. And here, the position is in a positive spot, but the velocity at 6 seconds is negative. So this would be moving towards the origin. So on that straight line movement, it's in a positive position because S at 6 is a positive value, but the velocity is negative. So it's in a positive spot, but moving backwards towards the origin, moving left or down. So I hope that makes sense. Please give the homework questions a try. And I know it's a lot of terminology, but hopefully this was helpful. And make sure that you post or ask questions if you need some more help.